These guys? Yeah. Okay, so if I go to 45, first of all, the way you spot the difference between calc and non-calc is, are these angles your special angles? And they are, which means non-calc. So on my 30, 69, there's two triangles happening here. This left triangle, which would be 30, 60, 90, opposite the 30 is A, opposite the 60, which would be at the top here, is A root 3, and opposite the 90, which is not there but would be there because it's perpendicular, is there. So the only one that I have the actual value for is the 2A one, which means A is going to be 4.5 or 9 over 2. You could have answered it either way. So then the Y would be just A, which is 4.5, and the X would be 4.5 square root 3. God bless you. Then you've got a triangle on the right you have to solve. And it's another 30, 60, 90 triangle, but the sides are reversed. Opposite the 30, which is at the top, would be your A. Opposite the 60, which is now at the left, would be your A root 3. And opposite the 90 is your 2A. So on the left is the only one I have the value for, which means 4.5 equals A root 3. You'd have to divide by root 3. A would equal 4.5 over root 3, and then you'd have to rationalize 4.5 root 3 over 3. Normally, you don't leave a decimal in the fraction, so you'd like move both the numerator and the denominator. I don't think you'll get like the decimal mixed in with the radicals, but if you did, you'd have to move this and this, and then it's simplify it, like you can put 15 in both, so it'd be 3 root 3 over 2. God bless you. That's whatever side this is, so that's Z. And then W would be 2 times that. So 2 times 3 root 3 over 2 would just be 3 root 3. So I think if you can do that without the decimal part, you should be okay. But you would not have a calculator on your 30, 60, 90, and your 45, 90 triangles. So the bottom one is the 45 and a 30, 60, 90 built in. The only value you have is on the 45 one though. So if I start there, this would be A, this would be A, this would be A root 2. So if 15 is on the A, then P is also 15, and R would be 15 root 2. Then you have to go to the triangle on the right. And the side lengths are different. In a 30, 60, 90, the Q is where the A is. The R gets your A root 3. And the opposite, the 90, where the T is, gets the 2A. So then if 15 root 2 equals A root 3, you have to divide both sides by root 3. And then rationalize. So you get 15 root 6 over 3, or 5 root 6. That's what Q is. And T would be 2 times that, or 10 root 6. Those are tricky because they're compound. There's 2 together. Yeah. Z was 3 root 3 over 2. Everybody else is good? Yes? All right, so remember this. All right, we're going to start with the end of 5-4. So this would be part 2 of 5-4. We did these slides. We solved our triangles. We set up and solved the triangles. And then we ended with these where you're given the 2 side lengths and you're not given anything about the acute angles. So for something like number 6, I would start by setting it up. I would label A, B, C. I'm going to make C the right angle because it told me in my directions. So make sure you're reading directions. The side A is opposite capital A, so lowercase a goes opposite capital A or angle A. And then side C would go opposite angle C. Those are the two you're given. So the first thing you want to make sure is what is it that I'm looking for, and it's anything that's missing. So I need angle A, I need angle B, and I need side B. You can, for this one, you could literally pick any order to solve for. I tend to jump to the Pythagorean theorem just because it's the thing you know the best. If you're given the two side lengths, then I can solve the third side length, so this would be B. Using the Pythagorean theorem, make sure you put them in the right spots. So the C is the hypotenuse, that's the one that goes by itself. And then I would basically just subtract this. And B squared is going to equal 39.7 squared minus 26.5 squared, which is 873.84. I'm not going to round that. I'm going to square root it. And I get B is 29.56. So because it tells me to round to the nearest tenth, now I'm going to round that to 29.6. That's side B. Questions on that one? Okay, now I've got to find the two angles. And again, it doesn't matter which angle you start with, but do not use B you just found. 1, it is rounded, so it is less accurate. 2, if you found that wrong, you will continue to get the rest wrong. So you want to stick with the information that they gave you. If I'm trying to find the measure of angle A, I have the side opposite it and the hypotenuse of this triangle, which means you're going to use which trig function? Good. So I'm going to say the sine of A equals the opposite side, which is 26.5, over the hypotenuse, 39.7. And then when I'm looking for the angle, I do sine -1 of that fraction. So second sine 26.5 divided by 39.7. And I get angle A would equal 41.87, which is going to round to 41.9. Now, when I go to find B, the fastest way, so if like you're worried about time, the fastest way is to subtract that from 90. But again, that's a number you found, okay? So you want to make sure that if you had the extra time, you would do it the other method, which is using the information they give you. If I'm trying to find B this time, I've got the adjacent side and the hypotenuse, so I would use cosine. I would say cosine of B equals adjacent, which is 26.5, over hypotenuse, 39.7, and then I would do cosine -1 of that fraction. And I'd get angle B is 48.12 or 48.1 degrees. And these together should add up to 90 degrees, and they do. So that's a way to check it. Bella, did I answer your question?
No, I was wondering if we're taking the test and we're filling everything in and we don't have enough time to, like, it would be faster if we just use the points that we found. Would we get points taken off for that if it's like a similar answer, or would it be partial?
The problem is if the points that you found are wrong. That's where the problem lies. If they're right, no. If they're wrong, yes. And this, because that can happen, this will not be a multiple choice part because you could be off by a tenth and still technically be right, depending on what you're using. So this would be on an open-ended portion, okay? Anything that you're rounding calculator-wise is probably not going to be multiple choice. We haven't finalized it yet, but probably not going to be multiple choice just because of that reason exactly. You might be a tenth off and still get full credit. If you get it wrong, obviously if you find one wrong and then you use the wrong one, that, I don't know if you'll lose full credit, but you're going to lose more credit than if it's just a tenth off because you used something that was rounded. You're welcome. Questions before we move into the last part? So any questions on solving the triangles, whether they for the sides or the angles? Because that's what the last three slides were. Okay, so then the last thing we're going to do, and there's still two parts to this, is strictly calculator based. So this is where you have to be so very careful. This is where practice is going to come into play because there's no way to give partial credit on this. It's like either all right or all wrong. Rounding is going to obviously be stuck to this, like if you round off on it's the nearest tenth and it's off, you're going to lose points because there's only one answer that should be correct, okay? So with these, and you might start with something like I'm going to put in here because we'll baby step our way in. But let's say it says cosine of 35.6 degrees. If you are finding the cosine of an angle, you literally just type it in as though it is. Cosine of 35.6, and I would get 0.8131. The instructions say round to 3 decimal places. That 1 is going to drop off, and my answer would be 0.813. You'll also see it like you see number 8, degree, minute, second notation can come into play here. So you'll also make sure like you know how to convert. So it won't just be a straight up conversion question like it was on the quiz. It will be built into those. It would be find the sine of that or find the cosine of that or tangent of that, not straight up convert. So you're going to have to convert in order to answer the question, but it won't just be just that. If it's a reciprocal function, which are the rest of these, then we do 1 over whatever that is. So I would do 1 over the cosine of 31.67. 1 divided by the cosine of 31.67 is 1.149. This 9 is going to bump up that 4, so it's 1.175. Yep. I made it up. I said let's add in 1 before we get to the reciprocal ones. Yeah. For 8, you could literally figure out what this is by using your degrees, minute, second notation. So I could do 131, second apps, get the degree. 45, second apps, get the single tick mark. And 25 alpha plus to get the double. And I get 131.7569. You need to keep the 3 decimal places if you're going to do this. So this one bumps that up. And I would make that 131.757. Yep. Yes. This whole thing has to be in degrees because we're hitting those trig functions. Yeah. Like next test, you're going to have to worry about going back and forth between the 2, degrees and radians. This one, it's all degrees. Yep.
Oh, so we can keep it.
You're going to reset it at the beginning of class. And then I'm going to be like, don't forget, you're in radians. You're going to switch it back to degrees. And then you can keep like that for the whole test. Yep. So then this would be 1 over the sine of 131.757. And I get 1.3405. The 5 is going to bump it up. So I get 1.341.
Oh, you use your rounding?
You can, as long as you keep the 3 digits. The other option is to literally type it in as 1 over the sine of 131 degrees, 45 minutes, and 25 seconds. You could do either one. 131 degrees, 45 minutes, and 25 seconds. And it rounds to the same thing, 1.3405, so it bumps it up. You get the same answer either way. Because it's cosecant, so you have to find this. You do 1 over sine. Right? Your calculator doesn't have cosecant or secant or cotangent buttons. Yeah.
There were some questions that only was a number and a degree and then a number and then.
Yeah, that's what we're going to do next.
Oh.
Yeah. Is that what you mean? Like the one where it says find sine of theta if equals this?
Yeah.
Yeah.
And it didn't have the last number.
Oh, if it doesn't have the last number, like the seconds, you just don't need it. You just leave it off. Yeah. Okay, and then 9, cotangent. So this would be 1 over the tangent of 81.8. And I get 0.144. Now, as standalone questions, those should be very easy, but what I'm about to teach you makes them confusing. So you have to be really, really careful. If it says trig function next to an angle and there's an actual value for an angle, you're going to do it the way we just did it. Now we're about to flip-flop it. So that's where it gets confusing. Valeska.
I'm just double checking for the second part of it. Can it be like a decimal, 25.6?
For the second part of it.
Like the seconds, like
Sure.
Okay.
Yeah. Like this, can that be 25.6?
Yeah.
Sure. Okay, so notice the difference on the slide we were just on and this slide. There was no theta next to the trig functions on the last one, right? It said find sine of something or cosine of something or cosecant of something. This is saying find theta if this is the sine. So this is the -1 buttons. This is the flip-flop. You want to pay attention. Is it asking for the angle? And if it is, we use all the -1s. So we're going to either use sine -1, cosine -1, or tan -1. These also have more than one answer. Just like when we did it before, we said all students take calculus. We found the reference angle, right? And then we put it in its quadrant. You're going to have to do the same thing here. There are going to be more than one answer. We're looking for it on the whole interval of 0 to 360. I promise you if you practice these eventually get to be quite easy, but in the beginning it's a little confusing. So if you're distracted or you're doing something other than paying attention, stop. Okay, yeah.
Is it always gonna, like, could it tell us, like, from 0 to 270?
It could. It usually doesn't. But it more than likely would say 0 to 180 if there's a difference on that. So you'd just be giving one answer. That's all. Yeah. But no, most likely you'll get 0 to 360. Okay, so we're trying to find the value, which means for 10, I want to find the angle that has a sine of 0.67456. So I'm going to do sine -1 of 0.67456. Second, sine 0.67456. And I get theta to be 42.4199. It said to do 3 decimal places again, so that 9's going to bump the second 9, which is going to bump the 1. And that's 42.42 degrees. And that is one of my answers. But according to our all students take calculus, what other quadrant has a sign that would be positive? Like sign as in, like the trig function sign. Where else is the trig function sign positive? It's in the first and the second quadrant. So we have the one in the first because 42 lies in the first. We need to figure out what angle in the second quadrant has a reference angle of 42.42. So I do the 180 minus 42.42. And the other angle is 137.58 degrees. Yep. It says 180 minus 42.42. So now here's the good thing about these. These are easy to check. If I find the sine of 42.42, it should be 0.67456. If I find the sine of 137.58, it should be 0.67456 or close because we rounded. So sine of 42.42, I get 0.67456. Sine of 137.58, and I get 0.67456. So these are easy to check. Yeah.
And because it's sine, it's positive in the first and second.
Correct.
And that's why you're doing 180 minus.
Correct. All right, now we're going to do tangent. So I'm going to do inverse tangent first, tan -1 of 1.45. And I get theta is 55.4077. So 55.408. And because tangent is positive in this question, which quadrants is tangent positive? First and third. How the heck? All right, so that it's in the first quadrant, which means I keep the 55. That's one of my answers. And then I have to find what angle would have a reference angle in the third quadrant of 55, which means I do 180 plus 55.408. And I'd get 235.408. And again, I can check it. Tangent of 55.408, 1.4500, and tangent of 235.408, 1.4500. Camilla.
Is the first angle that we found 55.4, is it always the A?
No.
The first quadrant?
It is always the first quadrant, but we can't always keep it as an answer. We're going to get to that when we get to 13. Actually, I'm going to add in before we even get to those because they get more confusing when we get to reciprocals. Let's say I had sine of theta equals negative 0.45. Let's just jump to that one, and then I'll go back to 12 and 13. So when I'm trying to find the sine or the cosine or the tangent, any of them, and it's negative, the first thing I'm going to do is find this inverse one of the positive value, and that's going to give me my reference angle. So I'm going to do sine negative 1 of 0.45. And my reference angle is 26.744. But because I want it where it's negative, I'm going to pick the quadrants where sine's negative, which is third and fourth. That means I cannot use 26.744 as an answer. I won't get the negative on it. So I have to find in the third quadrant, I would do 180 plus 26.744. And that's 206.744 degrees. And then in the fourth quadrant, I do 360 minus that angle, 26.744. And I get 333.256. And again, we can check them. Sine of 206.744, negative 0.45. And sine 33.256. I just hit the wrong button. Sine 333.256, negative 0.45. Yeah.
So the only thing you do different is that instead of looking for what's positive, you look for what's negative?
You look for where, right. But when you put it in the calculator, you put it as though it's positive, and then you would find it where it's negative. Yeah.
And 26.744 would be the answer for like the first quadrant.
If it was positive, I could have kept it.
You can't use the first quadrant because it's negative.
Correct. Yep.
Could there be ones that are plus and minus and you'd have 4 answers?
Sure. I don't know if they're on the homework or anything like that, but could they exist? Absolutely. And then it would be all 4. Yep. Actually, no, because they won't put the plus and minus on the value. They would have put it on the angle. So that you won't get that kind of question. Yeah. The other kind of question before we move into that last one is ones in which it can't happen. Sine cannot be bigger than 1. Cosine cannot be bigger than 1. So if I had sine of theta is 1.5, your calculator will catch it. If I do sine negative 1, I hit second sine 1.5, and you get an error. And you're like, Miss Chris Lesler, something's wrong with my calculator. Nope. There is no angle possible there. It's not possible. Or no solution.
And I cannot think of like any of those intervals in here.
So if it's bigger than 1, it would, remember for sine and cosine, it can't be bigger than 1 or less than -1. For for cosecant, -1 to 1. So sine and cosine have to be in here. They'd have to be in between. Secant and cosecant have to be out here. So, which means like if it said secant 0.4, you can't do it. But I'm going to teach you how to do those in a second. But you can't do this. This is not possible. Okay?
Sine can be -1, just not less than it.
Correct. If it's -1, then it's 90. Because it would be at the top of your quadrant. Tangent and cotangent can be anything. Yes, you can find the sine of anything. And you can find the cosine of anything. Yep. Okay, so when you get reciprocal functions, and this time they're both cotangent, but it could be cosecant, it could be secant, it could be, those are 3. It could be any of those. You do not do 1 over tan -1 like we do when we're finding the actual value. You do tan -1 of 1 over 1.27893. So you flip the value, not the angle. And that's where people get super confused. So if the theta is what you're looking for, we do, on a reciprocal one, we do 1 over the actual trig value, not 1 over tangent. And it comes because I would have to flip both sides. Like if this was, if I actually went through the logistics of why this is the way that is, if you're like one of those people that wants to understand it. If I do 1 over tangent here, I have to do 1 over 1.2789 there. I'd have to do it to both. So that's where this comes from. Tan -1, so I'm going to hit second, tan 1 divided by 1.27893, and I get theta is 38.022 degrees. My cotangent is positive, so I want it good. First and third, I get to keep this one because that's the one in the first one. And then I would do 180 plus that angle to get the one in the third quadrant. And I can check this by doing 1 over the tangent of 38.022. And I get 1.27892 in rounds. And I could do 1 over the tangent of 218.022. And I get the same value. Yep.
Is that only for cotangent or is it for cosecant?
It's for all of them. So if it had said cosecant, of theta equals 1.2789, any of the reciprocal ones, I would do sine -1 of 1 over 1.27893. Any of the reciprocal ones. Cool.
How do you check it again?
You do you do 1 over tan -1, 38.022, like we did on the last slide. So when you're looking for the value, you do 1 over. When you're looking for the angle, you do the tan and then the 1 over. Yep.
I don't understand how, like, the one that you get, is that always the first one?
It's the first quadrant, but you can't always keep the first quadrant. So, like, that's a perfect segue into 13. Look at 13. What's true about the sign there? It's negative. Cotangent's not negative in the first quadrant, so I can't give a first quadrant answer for that one. Does that make sense? I still find it the same way. So I do tan -1 of 1 over -1.27893. Oh, but I make it positive, sorry. Make it positive when you find it. 1.27893. And that theta is 38.022, just like we found. But that's the first quadrant angle, and I can't keep it. So tangent and cotangent are negative in second and fourth. which means I'm going to do 180 minus the 38.022 that we just found. And that's the first answer, 141.978. And I do 360 minus the angle I just found. And I get the second one, 331.978. And then again, to check those, it would be 1 over tan of 141.978 and 1 over the tan of 331.978. Camilla?
When you're checking them, you don't have to put tan -1.
No, because you're finding the tangent. You have the angle this time. When the answer is the theta, that's when we do the -1s. When the answer is the actual trig function, then we use the regular buttons.
And when we're checking something like secant, and cotangent, when we check, we always have to put it 1 over.
Correct.
Because it's like.
Correct.
Alright.
Valeska.
So you do it normally except like the one, you do 13, like 12, except finding
After you find words positive. Yep. So after you find words positive, that's your reference angle. And then you figure out which quadrant you need to put it in. Based on that, it's negative. All right. So if it said tan 1.24 or tan theta equals 1.24, what button am I using and how do I set up the first one? Normal button, tan 1.24. The second one, the tan -1. If it said cos or secant 1.24 or secant theta equals 1.24, the first one I'd enter how? 1 over cosine 1.24. And the second one? Cosine -1 of 1 over 1.24. So if theta is involved, the cosine does not go in the bottom. Okay, it's the cosine first and then the 1 over. I would say that's the most confusing part of this, is figuring out when to do it. So if you're looking for your theta, you enter the trig function first, then the 1 over. If you're looking for the actual angle, you do 1 over. Yeah. Sure. Questions on the homework from, let's do the 5-3 first.